Hello and welcome to our TI Technology webinar hosted by Texas Instruments Australia. So we're excited to bring you today's topic, Discrete Random Variables from Unit 3, Topic 5 of the QCE Mathematical Methods course. My name is Brian Lannon. I will be your host for this event, and more importantly, your panelist, David Tynan. Hello, David.
Hello.
Who is also a co-writer of a book from which these activities are taken. David will be showing you where that book comes from, and I will also be posting in a link for you to download if you don't yet have a copy.
Thanks, Brian. And hello, everyone. As Brian mentioned, the things that you will see in the webinar tonight are directly from a new publication, which is a teacher resource book for the TI-nspire CX2T. And I'll just show you a couple of pages from here to give you the look and feel of the book. There will be printed copies available at some stage, and obviously there's a digital PDF as well. So if I move to the second page, so Brian very humbly didn't mention that he's also an author for this book. But here's the table of contents. It covers units 1, 2, 3, and 4 of the Maths Methods course, and applications of the technology in each of those topics or subtopics of the methods course. The next page is an introduction to the book and gives you an idea of what it's about. There is also a link here, and in the link that I'm now highlighting, that will take you to a page, a web page, which will allow you to access the PDF directly. So I'm going to click on this link now, and it opens the TI page relevant to Queensland. And if I scroll down to the bottom of this page, I can see on the right-hand side a list of the Queensland ebooks, which includes the methods book, which we're talking about. There is also a link to the specialist book, and later on this year there will also be one for general maths. So I thought that would be useful information for you. So if I just will go back to this document. Now, what we're looking at tonight, as Brian mentioned, is the discrete random variables, which is topic 5, which I'm pointing to now. And if I click on that in the PDF, it takes me to this page. So it's page 50 of an 80-odd page book. And this is the first activity. So tonight, we will be just focusing on topic 5 or 3.5 in this book. And that's one activity. There's another one on Bernoulli distributions, a little bit on binomial distributions, and then an extension into solving a binomial random variable problem. So there are 4 things that we're going to do tonight. And if I go too fast, or I make a mistake, or I go too slow, you might find that looking at the PDF will allow you to do the same things. So without further ado, I'm now going to jump to the calculator via the teacher emulator software. So I'm going to try to reproduce what those 4 problems are about, and this is the first of them. And I've copied and inserted a screenshot of that first problem. So the first problem is just about general discrete random variables. And so there's a table which lists the distribution of a particular random variable, and it's asking you to find the expected value and variance, and then also the bounds within which 95% of the values of X are expected to lie, and also then to create a graph of that distribution. So that's our goal. So the first thing I'm going to do to start on that problem is to just insert a calculator page. And on the calculator, if you were to press Control-I, it will create a new page and allow you to choose what you would like to have on this page. So I'd like to add a calculator page. So I will do that. And so now I have a blank page in front of me. Now, if you recall the information on the previous page, which has the X values and the probabilities, I'll now enter those and store them. So the first thing is to store the X's. So I'm going to type X and then Control, and you end up with a colon equals. So X will be assigned the following values. Now, because it's a set of values, I'll use Control close bracket to insert the parentheses. And now I'll type in 0, 1, 2, 3, 4 and enter. So that's assigned to X a list of values. I'll do a similar thing for the probabilities. So I'll just type PROB and I'll do Control and then that key there, the templates key. And now I'm going to do another set of values, and these are the probabilities: 0.05, 0.2, 0.35, 0.25, and 0.15. Okay, so now those probabilities have been assigned to the newly defined variable prob. Now, what I'd like to do is just do a quick check I didn't enter anything in incorrectly in those probabilities. So if I just say I want the sum, so SUM brackets, and then I can just type prob, or I can press var. And then if I press the var key, I get the variables that have been defined, and put prob, it's black to show that it's been defined, and enter. And comfortingly, it is telling me that the probabilities that I've entered in do indeed add up to 1. The next step is to find the expected value of X. And so I'm going to define a new variable called EX for expected value of X. And again, Control templates, and I get the colon equals for assigning. And I'm saying that I want the sum of the X values multiplied by the probability values. And that tells me that the expected value is 2.25, which seems reasonable. Now what I'll do is enter var X, because I wish to calculate the variance of X, and I'll create a formula for that. So Control template gives me the assign key. And now what I'm going to do is I need the sum of X squared multiplied by the prob minus the previously defined E of X all squared. So the expected value of X squared minus the expected value X all squared. And that tells me that the variance is 1.1875. And now for question A, it also asks for the bounds for 95% of the values. And so finally in this section, I can define a set or an interval. So Control brackets, and I get the parentheses again. And I'm just going to type the expected value minus 2 lots of, not the variance, but the square root of the variance. So I'll do of var x, comma, ex plus 2 lots of the square root of the variance. And so that gives me the bounds. Now, if I'd like a slightly rounded version of that, I, of course, can just say round of the answer to 2 decimal places, we'll say. And so we expect that 95% of the values of x to be between 0.07 and 4.43 rounded to 2 decimal places. All right, so that's it for part A. For part B of the question, we're just trying to create a graph of this distribution. So I'll just go back to our calculations, and I'm going to do Control-I to insert another page, a third page. And I wish this to be a data and statistics page because I want to do a statistical graph to plot these probabilities. So that doesn't do anything immediately, just randomly places the dots. But if I press the Tab key now, it says, what would you like this variable to be? Well, I would like that to be the x values. And if I press the Tab key again, I would like that to be the probability values. And so that's a simple plot of the discrete, the probabilities for this scenario. So just finishing that problem off, it would be possible to do this with another set of x values and another set of probabilities, and it would just be a matter of recalculating the other parameters such as the expected value and variance, and then the same calculation or analysis can be completed. Okay, so I think that's enough for that problem. Let's move to the next problem, which is working on a Bernoulli distribution where n is 1. And it's been asked in QCE methods exams before, and that is that if you are given the standard deviation, to find possible values of E of x. So we're going to complete that analysis. So I'll insert again, Control-I, and I wish to add a calculator page for this problem. I've called this, this is in the second problem, so none of the definitions exist that we used in the previous problem. So just to make that point, if I press the var key now, there's nothing that has been defined. We've separated by making a new problem. Okay, so in this question, it says that the standard deviation is 2/5. So we can use the formula that we know for the variance of x for a Bernoulli distribution and calculate the following. We can type nsolve, or we can press menu, algebra, and numerical solve. So nsolve, and let's type the variance. So it's p times, in brackets, 1 minus p. And that is known to equal not 2/5, but 2/5 squared. So that's the equation that we're going to try to solve numerically. nsolve also allows you to put in a guess. And what I'm suggesting is that you put a comma and then just say that you're going to start from p equals 0. And remember, we're going to try to find a p-value for which this works. Okay. So if I press enter, it says that p-value of 0.2 or a fifth would be suitable. Now I'm going to try the other end of the bounds of p, which is that p is 1. And so starting from that end, it locates that p could also be 4/5 or 0.8. There is an alternative way to do this, and that is to use another solving technique on this calculator called polynomial roots. So it is possible, I'll use the menu. So if you do menu, algebra, polynomial tools, and real roots of a polynomial, you'll get the command polyroots. And so it would be possible to type in p times 1 minus p. Now, if I tried to say equals 2/5 squared and comma p, it will give an error. And the reason is that polyroots is actually looking for just the polynomial expression, not an equation. And so we'll try to edit to make this correct. If I just said the polynomial is not equals that, but minus that. So it's like moving the 2/5 squared onto the left-hand side. And that's the expression that we're going to try to find the roots of. And that also tells us both possible solutions for p. Okay, so I think that's probably enough for that problem. And so I think we can move to the next problem, which is visualizing the distribution of a binomial random variable. Now, we're going to set this up as a template that you'll be able to reuse for a number of, multiple scenarios that you might encounter when setting or doing binomial random variable based problems. So we're going to create a notes page. So if I do Control I, and for this third problem, I'm going to add not calculator, but a notes page. And for those that haven't used a notes page before, this is a combination of text and live mathematical calculations. More of this a little bit later. So I'm going to, first of all, just type some text. So using the keyboard, binomial, RV graph, and press enter. And now what I'm going to do is define some variables. In the notes pages, these are live and editable. And the way that you do that is you insert a box called a maths box. So I'll just do it via the menus first. So if I press menu, insert, and math box, you'll notice it says Command M there, or Control M if you're on a Windows computer or on the calculator, but the same command exists. So if I do that, you'll notice I get a little box, sort of a black dashed box and then a red surround to it. And so what I'm going to do with that maths box is type N and then Control templates. So I'm going to assign to N, and I'll just make a value at the moment of 8 and enter. So you'll see that that in blue is the input, and then that's the green is just the output, which echoes that. The next one is to set the p-value. So the p-value, so p colon equals, or P control template will give you that key. And I'll just type in 0.25. So I'm assigning to P an initial value of a quarter. Okay, now I've got another maths box there. Until you tell it otherwise, it will just assume that you're wanting to continue constructing maths boxes. So now we're going to put in the R values. So R, control template. And now we're going to do a sequence of values. So I'll type in SEQ brackets, and I'll just make up these letters. So X, comma X. So it's a sequence of values using an expression, which is just X, using the variable X. And I wish it to, the sequence to be generated starting from 0 and going up to N. And I don't have to, but just to be clear, I'm going to do comma 1, which means that I want it to increment in steps of 1. So you can see that's generated 9 values from 0 up to 8. So now we've got a fair way. And now we'll calculate the probabilities in the binomial probabilities. So prob and then control template to get the assign key. And now I'm going to type in the formula for calculating a binomial probability. I'm going to use the shortcut of just typing NCR for the number of combinations, open brackets, NCR, and then it'll be N, comma, R, close the brackets, multiply that by P to the power of R, and multiply that by 1 minus P to the power of N minus R. And that's calculated my probabilities. So that's all very well. So I've calculated the values, but I haven't got my graph yet. So now what I'd like to do is to add a page. So I'll do Control I, and I'd like to add a data and statistics page. And in the data and statistics page, I'll click down here. I could have pressed tab. I'll put the R down the bottom like I did before, and the probs up here. And so now I have a plot of the binomial probabilities for the R values in the scenario defined. So it would be nice if there was a way on the graph to just modify to maybe have a slider for the R value or a slider for the N value. So for the example, I think I'd like to do a slider for the N. So on this plot, if I press menu, actions, insert slider, I then get a dialog box which is asking me for the settings for this slider. And so the variable that I want to slide is N, and I'd like it to be start at 8. I'd like the minimum to be 8, and I'd like it to go up to 20, and I'd like it to go up in integers. I'll scroll down to see if there are any other options I need to change, and I think I'd like it minimized so it doesn't take up too much space. So if I click on that and press OK, I've now got the slider showing here. If I want to change this, if I press this arrow here, you can see it is calculating automatically. If you choose a value that makes the view not as good, you can, in the middle of the screen, just press Control and then Menu and zoom data, and it will it'll change the window dimension so that you have a better view of what you're looking at. Okay, I'll just move back down to 8 for the end value and redo the window. I should also say that you can go to the menu and use window zoom data as well. That will achieve the same thing. But it is a bit of a shortcut on screen to just do Control Menu and choose zoom data that way. All right, so now we know how to produce that plot. And we'll just do one more thing back on the notes page. It would be nice if we could look at these probabilities in a more easy to view manner. So what we're going to do is use a formula that will give a grid structure or a table structure to those values. So I'll just lead you through this command. All the instructions, of course, are in the book, but I'll just follow the steps. So if I am inside a maths box and I press Menu, Calculations, Statistics, List Operations, Convert List to Matrix. So that gives that command, list to matrix. It's quite a few clicks to do that. And then the next thing I want to do is to, inside that bracket, to press again, Menu, Calculations, Statistics, List Operations, and Augment. Now, augment in this context means to join together or add something to the end of. So what we're going to stick together are two lists. And the two lists that we're talking about are the R values and also the probs values. So that will stick them together, close that bracket. Now I need to put a comma here because the list to matrix command, you need to tell it how many rows or columns that you're talking about. Now, in the scenario that I'm doing it, 2 rows, I just want to specify that the number of columns is not 8, but 1 more than 8, that is 9, because there's 9 elements. So if I just type n plus 1, that now gives me a structured table where the first row are the R values and the second row are the probability values. Now I'd like to show you another feature which relates to the display precision of individual objects on a notes page. So if I click on the command and press Menu, Maths Box Options, Maths Box Attributes, I can check that option, and now I have the following things: hiding the input and output or show or otherwise, inserting a symbol. The display digits is what I really want. What I would like is that the output is displayed to 4 decimal places. And so I'm going to set it at fix 4. And so that means that the output, you'll now notice, the probabilities are all to 4 decimal places. Okay, now, one final thing on this scenario, on this notes page, is to write this command. I'll copy it and I'll paste it to another maths box. But I will do all of this in a bracket, bracket, and then outside the bracket here, I'm going to press Menu, Calculations, Matrix and Vector, and Transpose. And a transpose will change it so that instead of it being 2 rows and 9 columns, it's 9 rows and 2 columns. And the only real value in this is that it just gives you an easier way of viewing it. And because you're setting it up as a template, it will always be there, whether you've changed the scenario or not. It will automatically recalculate that. And finally, because we've gone to the trouble of doing that, we can say that we'd like it to be bold to stand out, and we can even change the color, but I won't bother. Okay, so that's the end of the third problem. And the final problem that we're going to do is an application problem. So about a salesperson that has a 30% probability of making a sale to each customer who enters the store. Each sale is independent of all the other sales. And we have enough information to infer that a binomial distribution will be appropriate with an n value that we can determine, and we already know the p-value. So we need to find the probability that the number of sales exceeds 20 on a day when 40 customers enter the store. So in a sense, n is 40. That's the scenario that follows through in B and C. In B, we need the mean and the standard deviation of the number of sales. In C, we're finding the interval within which 95% of the days are expected to be. And then the inverse binomial question, where we're asking what is the minimum number of customers who would have to enter the store so that we have a 90% chance or more of making at least one sale. Okay, so let's get into the problem. First of all, we'll press Control-I to add a page, and we want to start with a calculated page. So we'll do part A, which is the probability that on the number of sales exceeds 20 on a day where the 40 customers enter the store. Okay, so we're essentially, I'll use the menu command. We're going to use the inbuilt binomial probability functions. So the menu and then probability distributions, and then I can see I need binomial CDF for a cumulative D value. Now, the number of trials is 40. The probability of individual success is 0.3. The lower bound is not 20, it's 21, and the upper bound is 40. So what we've got now, this screen is basically like a wizard for allowing you to construct the required probability. So if I click OK, this tells me that the probability is approximately 0.002 of that occurring, which doesn't seem to be particularly great. Okay, now the second problem relates to finding the mean and the standard deviation. Now we'll do what we did last time, but just do the binomial known formulas for mean and standard deviation. So I'll define EX, so type EX, control template to get the colon equals for assigning, and EX is just N times P. So we can just write 40 times 0.3, and now we know that that's been defined. And we can also do the standard deviation. The standard deviation of x is equal to the square root. So control x squared, and it's 40 times 0.3 times 1 minus 0.3. And that is the value of the standard deviation. And as we said before, it's possible to use the set brackets, parentheses, and construct the interval. So it'll be EX minus 2 times SDX and EX plus 2 times SDX. And so those are the values, but of course we might choose to round them to the nearest, round the previous answer to the nearest whole number. And so we have the interval from 6 to 18. So that's answered part A, part B, and part C of the problem that we've been set. And the last question is a little bit more involved. So the minimum number of customers who would have to enter the store to have a 90% chance or more of making at least one sale. So what we're saying is we want the probability that X is at least 1 to be at least 0.9. So there are a couple of ways to do this. So we'll do the first method, which is sort of from first principles. So we'll use the binomial probability CDF. Now, if you try to type that the n value is, the problem is that you don't know the n value. You're going to try some n values. So if you just said, well, let's call it the n val, and the probability of success is 0.3, that's the p-value. The lower bound is not 0, it's 1, and the upper bound should be up to the n val. That's what we're trying to calculate. But the problem with that is that you'll get an error because you're using a variable rather than a number. So the way around that problem is just to go to that command and just make an adjustment to say, well, look, what I'd like to do is say to calculate what the probability would be if I set the n value, that is the number of customers, at a particular value. So to do that, on the calculator, after the command that's there, if you press Control equals, you'll get a pop-up box, and you want this vertical line, which is like the conditional symbol. It's like conditional upon a particular n value. So let's try n val equaling 5. So in a sense, we're just substituting in 5 for n val. We're not changing the value of n val. We're just asking the question, what will the probability be if n val was 5? Now remember, we need this to be bigger than 0.9. So if we press the up arrow twice and enter, that'll copy and paste it to the editing line. We can try 6. Still not greater than 0.9. So we'll try the next one, which is 7. So now we do have an n value that will work. We know that if 7 customers would have to enter the store for there to be a 90% chance of at least one sale. So that's the first principles way to do it. There is also another way to do it, and that is to use an inbuilt command for the inverse binomial function. Now, this takes a little bit of explanation, and it's explained in the book in a bit more detail, but just to summarize, I'll just bring up the command. Menu, probability, distributions, and we want inverse binomial n. Now, and slightly unfortunately, the way that this command works, it works from the left-hand side. So we want that the probability that x is at least 1 has to be greater than or equal to 0.9. That is equivalent to saying the probability that x is less than 1, or if you like, the probability that x is 0, is less than or equal to 0.1. And so that's the way that we'll enter this command. We want that the cumulative probability is 0.1. The individual probability is 0.3, and we want to have no successes. So it's like an inverse way of asking the previous, asking this question. And if I press enter now, it just tells me that I need 7 for that scenario. So if I was doing this with a class, I would be drawing a graph to make it clear why that works. So the kids would have to be confident about that. And I'll just do it one more time. Menu, probability, distributions, and inverse binomial n. So if I type the same information, 0.1 and 0.3, and I want 0 successes, we want this to be, and I'll click on matrix form. And just to show you how this is different and maybe a little bit more helpful, this now produces a matrix to say that if you choose 6, then that probability won't be less than 0.1. But if you choose 7, that probability will be less than 0.1. And thereby, that will allow you to assert that 7 customers, that's the minimum number. 7 is the minimum number of customers that would have to enter the store for that scenario to be true. Okay, so that is the end of that section of discrete random variables. I'll just take you back to the document just so that you can see from the start that the book covers all of those procedures and the relevant screens. Problem 1, problem 2, problem 3, and then problem 4. And you'll see there's quite a few notes to help you if you've forgotten any part of the procedure or the underlying maths for that. So to conclude, this book is out now and is available for all teachers to help them with the 2025 version of the Queensland Methods course as it relates to this particular calculator. We have tried as authors to cover some possible uses of the technology for each of the topics and subtopics for which it's relevant. And it turns out that that's pretty much all of the course, that there would be some application of this. And on that note, I think that that's all. So Brian, I might hand back to you. And if there are any questions or any other further comments that you would like to make, this will be a good time.
I quite particularly like your use of notes there and setting up the notes pages for these things, and a clever take to use matrices as well, whereas I've generally used the wizards. But very handy to have that all reinforced by the book, which leads to a question that somebody posted in the chat. They picked up a hard copy of the book at the Texas Instruments Learn, Energize, Connect event in Brisbane last year.
Yes.
And they, so they were quite pleased to see that you can also download electronic copies, both from where you demonstrated and the link that I typed into the chat. But the question was, are there also other similar resources for the other courses, for specialist mathematics and general?
And were you able to answer that for them?
I thought I'd flick it to you because I know that you know more about this than me.
Yes. So for specialists, there is an even larger teacher resource book, 160 odd pages, and that's also accessible from the same website that I spoke of at the start of the webinar. And under development at the moment is a third publication which is designed to support the general maths course, in particular the usefulness of the TI-30X Plus math print calculator, and it will be coming out a little bit later on in the year. So the summary answer is yes, there is, and we intend to put together one for the three main subjects in the QCE course.
Oh, terrific! Yep, and the general one is the TI-30X Plus that you mentioned. I've just got that on my next slide there. First of all, you see the link at the top of the slide for where these can be downloaded. Yep. The TI-nspire CX2T is the calculator in the middle of the screen there, that white one. So that's the more advanced calculator. But the TI-30X Plus, it's just a scientific, but it punches well above its weight in some of the things it can do.
Particularly in its exact form, capabilities, and its ability to work with variables and sequences and things like that. It's actually quite easy to use, but deceptively powerful.
Yes, well, you used sequences in your presentation today, so right. I don't know that has that capability, but it also has a very powerful statistics and statistical distributions package.
That's true.
So yeah, so we'll be looking forward to seeing that one. Okay, so thank you to participants for joining us for this event. If you do have any last minute questions, type them in now. Please send to all panelists. And because we'll be closing out shortly. When I do close the event, you'll be taken to a page where you're invited to leave feedback. And also, I think the landing page is then the TI Queensland page with links to further PD, the downloading of the books, of course. You also have the capacity to investigate previous webinar events that have been conducted, send the students into some online courses for the technology, which is very helpful. Good early in the year or late or at the end of the year activity, and of course a lot of these short demonstrations are also published on TI Australia YouTube channel. You've got QR codes there if you want to grab those. So in conclusion, thank you again for joining us. Thank you especially to our presenter, David Tynan, and also project manager and co-author of the Queensland Mathematics Resources book. And our topic this evening, Unit 3, Topic 5, Discrete Random Variables. We do have more planned for this series, so stay tuned. Hope to see you again soon.